Hello everyone. So this is just a review video on all the different ways we have learned on how to solve a trig equation. So our kind of basic, kind of like a linear way of solving using the square root property, using a greatest common factor, factoring, and then grouping. So again, nothing new in this video, just a review of all the different ways we have learned to solve. So here's kind of our basic way of solving. It's kind of like a linear equation. So remember, first thing we want to do is we want to get all of the x's on one side. So in this case, I want to get all of the cosines on the same side. So I think what I'm going to do is I'm going to go ahead and subtract this cosine from both sides. So we're going to end up with the square root of 3 equals -2 cosines. And now we want to go ahead and get our cosines totally by itself. So what I'm going to do is I'm going to divide both sides by -2. So we're going to end up with cosine equals the square root of 3 over -2. And now in order to solve for x, we have to take one more step. Remember, x is really an angle. So we need to go ahead and on our unit circle, figure out all of the places where cosine, where our x values are negative square roots of 3 over 2. So my unit circle is getting a little beat up, but we need to figure out all the places where the x is negative square roots of 3 over 2. And it looks like there's one right there at 5 pi over 6. And then there should be one more. So the other place where our x is negative square roots of 3 over 2 is at 7 pi over 6. And those are our two answers. All right. Next one we're going to do is kind of the square root property. So remember, when you're using the square root property, you have to get to what's being squared totally by itself first. So I think what I'm going to do is I'm going to add 3 to both sides. And then I'm going to divide everything by 4. So I'm going to end up with cosine squared equals 3/4. And now remember, in order to get rid of something that's squared, we take the square root of both sides. And again, very, very important, remember, whenever we add a square root, we also have to add that plus or minus as well. So the square root of cosine squared is just cosine. And then remember, when we take the square root of a fraction, we take the square root of the top. And then we take the square root of the bottom. And the square root of 4 on bottom is going to be 2. So now my solutions in this one, I need to find all of the places on our unit circle where cosine equals positive square roots of 3 over 2, or it could equal negative 3 square roots of 3 over 2 as well. So all of the places on our unit circle where the x is the square root of 3 over 2 or negative square root of 3 over 2. And it looks like that is all of our pi's over 6's that will happen. So I'm going to have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 as well. All right, next one then is using our greatest common factor strategy. I believe this should be setting. So we have sine minus 2 sine times cosine. So if you notice, I have two terms here, and each of those terms has a sign in it. So what I'm going to do is I'm going to factor out that sign as a GCF. So when I factor that out, I'm going to have a 1 left. Sine times 1 is sine. And then over here in this place, I'm going to have a -2 cosine left. And now there's nothing else I can do here, so I'm going to go ahead and set each of these pieces equal to 0. and solve. So I'm going to subtract 1 from both sides. And then I'm going to divide both sides by -2. So our answers are going to come from sine of theta equals 0 and cosine of theta equals 1/2. So using my new unit circle, I need to find all of the places where sine, and remember sine is our y values. So I need to figure out where sine, the y is 0. And it looks like the y is 0 at both 0 or 2 pi and at pi. And then we also need to figure out where cosine equals 1/2 as well. So where cosine equals 1/2. So it looks like that happens at pi over 3. And it also happens at 5 pi over 3 as well. All right. The next ones we're going to do then is our basic factoring problem. So kind of like a quadratic. So think if you have something like this, what would you do? So I'm going to go ahead and set up my parentheses. So in this case, we need to figure out what times what gives us a cosine squared. And hopefully you guys are thinking cosecant squared. Hopefully you guys you're thinking cosecant times cosecant gives us a cosecant squared. And now my last times my last has to multiply to my last. My only factors of 2 are 1 and 2. And now let's go ahead and figure out our sign. So I need a negative cosecant. So I think it's going to be like this. So -2 cosecants plus +1 cosecants gives us that negative cosecant. All right, and now it's factored, so I'm going to go ahead and set each of these pieces equal to 0 and solve. So it looks like I'm going to get cosecant equals -1 and cosecant equals 2. But we don't have cosecant on our unit circle. It's not super easy off the bat to recognize. So remember, we can look at those reciprocal functions. So remember, the reciprocal of cosecant is sine. And the reciprocal of -1 is just -1. So the cosecant of equals -1 and the sine equals -1. Those are the same things. Sine is just easier to recognize on our unit circle. And same thing over here. Reciprocal of cosecant is sine. And the reciprocal of 2 would be 1/2. So now on our unit circle, I need to find all the places where sine, where our y value equals -1. And it looks like the only place that happens is at 3 pi over 2. And then I need to figure out where sine equals 1/2 as well. So I have pi over 6. And at 5 pi over 6, the y values are both 1/2. All right. Careful. The last method, get that out of your mouth, please. Get that out of your mouth. The last method we learned then was grouping.
Can I do it like this?
And remember, grouping we like when there's 4 terms. So if you think of like polynomials, when it's something like this. So I indeed have 4 terms. So let's go ahead and samurai sword this baby right down the middle. And we need to figure out our GCF from this half. And it looks like I can take both a 2 and a sine out. And when I do that, I'm going to have a tangent squared minus 1 left, I believe. And then I need to get tangent squared minus 1 over here. So it looks like I just need those signs to flip, so I'm going to go ahead and take a GCF of -1 out. So now my two factors, I have a tangent squared -1. And if I put these two together, I will have a 2 sine -1 as well. All right, let's go ahead and set each of these pieces to equal to 0 and solve then. So this one, since I have a tangent squared, I'm going to have to take the square root of both sides. Remember, when I add a square root, I also have to add a plus or minus as well. So over here, I'm looking for where tangent is positive or -1. And over here, I'm looking for where sine is positive 1/2. So I think I'm going to start off with these ones first. We just found where sine was 1/2. Sine is positive 1/2. The y is positive 1/2. I have both pi over 6 and 5 pi over 6. And then we also need to figure out where tangents are positive and -1. And remember, I've written all of my tangents in orange on my unit circle, but it looks like it's all of the pi's over 4. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 as well.
Mom, I made it all. I make the big circle. Look at.
Oh, careful, don't rip it anymore, otherwise we'll throw it away. All right, last one. It is another grouping example. Maybe. So again, notice I have 4 terms here. This one is not equal to 0 though, so I'm going to go ahead and subtract that 2 over before I begin. All right. And now same thing, I'm going to split it right down the middle. And it looks like the GCF of this half, it looks like it can only take a cosecant squared out. And it looks like I'm going to have a cotangent squared plus 2 left. And it looks like in order to be left with a cotangent squared plus 2 over here, I'm going to have to take a -1 out. So my two factors, I have a cotangent squared plus 2. And I also have a cosecant squared -1 as well. All right, let's go ahead and set both of these equal to 0 and solve then. So over here, I'm going to have to take the square root of both sides. Don't forget to add your plus or minus. I, however, cannot, we can't do the square root of a negative. That is imaginary. So this would be one of those extraneous solutions. It's not going to work because of the fact that it would end up imaginary. We can go ahead and do this one though. So take the square root of both sides. Don't forget to add that plus or minus. Very important. We're going to end up with where cosecant is positive or -1. Again, since cosecant isn't readily on our unit circle, I'm going to go ahead and find the reciprocal function instead. So the reciprocal of cosecant is sine. So I'm really looking for where sine is positive or -1. And sine is positive or -1. The y is positive or -1 at both pi over 2 and 3 pi over 2. So those are our two solutions.